Well, welcome. I'm happy to see that you are watching your notes again. This video is going over Chapter 8, Section 7, and we're going to call this Section 7A. So what have we learned so far in Chapter 8? So far we've learned about greatest common factors and how to factor those out from binomials and trinomials. We also learned how to factor a four-termed or greater polynomial by grouping. And we learned what it means to solve by grouping in Section 8.5. So for Section 8.7, what we're going to talk about is factoring those pesky three-termed polynomials, also known as trinomials. There are a couple of different ways that you can do this. We're going to cover two of those options in this video, though there is a third video that covers another option for you as well. That would be Section 8-7B. So if you didn't like either of the ways in this video, that one might have another option that you might actually like. One thing that I do want to point out is notice this way of writing a regular trinomial. This is what we would call our standard form for a trinomial, our ax squared plus bx plus c. He's going to be important because we are going to refer to those coefficients for those x squared, x, and c as a, b's, and c's. It's a little bit shorter and a little bit faster to say, and it gives us a name for one of our options. So, good old-fashioned guess and check. Yes, to factor a trinomial, you can use guess and check. There are still steps for guess and check. Step number 1. Well, that is going to be write two sets of parentheses. These two sets of parentheses should be big enough to hold a binomial. Step number 2. Break down your first term. What I mean by break down your first term is think of some of the factors pairs that you could use to make that first term. Step 3, break down your last term. Also known as look at C and think of factor pairs that will multiply together to get you to C. Step number 4 is test your outside and inside to get your middle term. This is where that guess and check comes in. We're going to start placing things in our parentheses, foiling to guess and check and see if we can get the right trinomial. Of course, I already told you we want to use FOIL to check these. And be careful with these. You do want to watch your signs. It is very important that your signs on everything are right. So let's go to an example and see what good old guess and check is supposed to look like. If I go down my list of items, my very first step says write two parentheses. Very first thing, I'm going to open two sets of parentheses, big enough for a binomial to fit. Part 2 says break down your first term. By first term, it's talking about if you have it in standard form, descending order. So my first term would be my squared. I'm going to look at 2x squared. I like to write it off to the side, that way I can cross things off and see what worked and what didn't work, and I don't forget a set or accidentally already used a set. So if I'm thinking about breaking this into two separate parts, the x squared is always going to have two separate x's. They should not be together. Now let's think about 2. Well, 2 is 2 times 1, right? Are there any other factor pairs that give us 2? No, it's a prime number. So that gets me through part 2. Let's go to step number 3. Step 3 says take your last term. In this case, it's a positive 3. Again, I'm going to write that off to the side so I don't forget what all of my factor pair options were. 1 and 3. What are two things that multiply together to give me 3? Well, I know 1 times 3 is. Anything else? No, 3 is a prime number. So for this exercise, it's pretty short, and guess and check can be a pretty quick method to go through. If I was to go through this, I can take these, and I'm going to try putting them in places. The first factor always goes first. So I have 2x times 1x, which I'm just going to write as x. That first one, you can go ahead and just place them wherever you like. It's not going to make a difference. It's the second pair that you have to be careful with where you place them. All right, so if I'm going to put these second pair in, and I go fill in my spots, they're going to go at the end of both sets of parentheses since it's my end term. Let's just try this, 3 and 1. Now, if I do my FOIL to check and see what it is, I did my guess, here's my check. I'm just going to check for that middle term, so I'm just going to do my outsides. 2x times 1 is a 2x. And just my insides. So I also know I have a 3x. Does 2x plus 3x give you 5x? It indeed does, which means I happen to pick the right choice. So I know this was a positive 3 and a positive 1, and it worked out. All right, so that is our first option. The first option is guess and check. That one, it went great. We already plugged them into the right places. I didn't intentionally do that. I just happened to pick the right one the first time. And that could happen for you. However, if we had started off with my 1 here and my 3 here, and I went through and double checked, I would have gotten a 2x plus 2x times 3, which would have given me a 6x, and a 1 times an x, which would have given me a positive 1x, and that would have led me to 7x. That wouldn't have been right, and that's how I know that I needed to switch these. So I can get rid of, whoops. And that is why we decided that the 3 goes here and the 2 goes 1. So it could have taken a little bit longer. Step number 2, option number 2. I call this the AC method. If you're talking to Ms. Stauffer, you might want to tell her it's the product sum table, but they're the exact same thing. What we're going to do for this method is we're actually going to make our polynomial bigger. Our goal is to break our trinomial into a 4-termed polynomial. So let's look at our pattern here. When I look at the trinomial, everything's combined. But I know that that's the exact same thing as this side, where I have 4 terms. Here's what I want you to notice. We have 2 x terms here. We have a positive 2x on our 4 and a 15x. Our goal is to find a way to take that 17 and break it into 15 and 2. How are we going to do that? Well, our first step is to make the product sum table. So what is that going to look like? Well, we're going to draw a nice little 2-column table. On one side, we're going to have the product. I need 2 things that multiply to be a C. On the other side, we're going to have the sum. I need 2 things that add together to give me B. Where are that a, c, and b coming from, you say? Well, remember at the very top, I highlighted that ax squared plus bx plus c. That's where the a, c, and the b are coming from. A is going to be our coefficient of our squared term. B is our coefficient of our x term. And c is our constant. So again, when we're making our product sum table, we want AC for our product, which is where I call it the AC method. And for our sum, we want B. After we make our product sum table, we are going to break that middle term into two pieces. So we're going to take our x term and make it two separate pieces. Don't forget to put variables on them when you put them in the middle term. You don't want to confuse them as constants by accident. For step number 3, now that we have a 4-term polynomial, you guys already know how to factor those. We're going to factor by grouping. Just a refresher, that means we need 2 greatest common factor problems. And we should have matching parentheses. If we don't have matching parentheses, then we can't finish factoring it. So let's see what an example of option number 2, the product sum table or the AC method, looks like. All right, I'm going to start off by making a table. I know that I need the product on one side of A and C. Well, what is A in this problem? My coefficient of my x squared term. So my A is 2. C stands for constant. So I know my C is going to be 3. So product of AC means I need 2 times 3. And 2 times 3 gives me 6. As for the sum, I need those 2 numbers that I find to give me a sum of 5, which is my B term. All right, so here's what's going to happen. I am going to go and list our factors of 6. I know 6 is 1 times 6. I know 6 could be 2 times 3. There aren't any other pairs, right, that get me to 6? Of course, we could do both of their negatives as well. I could do -1 times -6 and -2 times -3. Here's the thing. I want them to add to a positive 5, though. So I can automatically cross off those 2 negatives. I could go through and say 6 plus 1, well, that equals 7. That's not a 5. 2 plus 3, that for sure equals 5. That is going to be my 2 new middle terms. So let's move on to step number 2 in the AC or product table method. Means I'm going to rewrite my polynomial. I have 2x squared. I write that the same. Instead of this positive 5x, I'm going to break it into a positive 2x plus my 3x. And then that last term stays the same as well. Add my 3. Now that I have it as a 4-termed polynomial, I can go ahead and factor by grouping. So let's group these into 2 factors. 2x squared plus 2. Don't forget to add in that extra plus there. 3x plus 3. I can go ahead and pull out my greatest common factor of each separately. 2, and that would leave me with an, whoops, I forgot an x. My greatest common factor of this first one is going to be a 2x. Open my parentheses. 2x times x gets me to x squared. 2x times 1 gets me to the 2x. Greatest common factor of 3x and 3 is going to be 3. Open my parentheses. I need a 3 times an x to get me to 3x, and a 3 times a positive 1 to get me to a positive 3. And of course, my addition sign in the middle. I finally finished that, and I have an x plus 1. It's the same in both of my parentheses, so I can write it down. And then I can go ahead and take what I have left from each one. I have a 2x out front here, and a positive 3 out front here. So again, I end up with an x plus 1 and a 2x plus 3. So those are the two different methods and two different ways to go through these. The first one is guess and check. The second one is the product sum table. So let's do a couple more examples just to be on the safe side, make sure we know what's going on. Let's go ahead and do number 2. And out of our 2 options, I'm going to use the AC method for number 2, or your product sum table. So let's very first thing. A is equal to, B is equal to, C is equal to, what do we have? Our coefficient for our x squared is going to be 2. My coefficient of my x is a negative 3. And my constant is a negative 2. Don't forget to bring those negatives with them, even though they say subtract up there. All right, I know A times C is going to be the left-hand side, my AC table. So I have a 2 times a negative 2, which of course gives me a negative 4. Other side of my table says I need them to sum up to a negative 3. Or in other words, I need to add them to a negative 3. Underneath my AC side of my table, write out some of my factors that gets me to a negative 4. So for example, I could do a negative 1 and a positive 4. If I added those, I have negative 1 plus 4 would give me a positive 3. Well, it's close, but it doesn't quite get there. We have the right number, but we need negative. In order to get to a negative 3, what we want to do is go ahead and write down a positive 1 and a negative 4. Positive 1 times negative 4 still gives me negative 4. Then 1 plus our negative 4 gives me a negative 3. Since I got a negative 3, which is my B term, I know these are the two numbers I want. And I can go ahead and rewrite my middle term. So I'll have a 2x squared plus a 1x. Don't forget to bring that x in there. Minus a 4x. And then again, my constant stays the same, minus 2. When we rewrite, the only thing we want to change is that middle term. We can copy straight down our first term, our squared, and we can copy down our constant. All right, I've got a 4-term polynomial, so of course we know we're going to factor by grouping. 2x squared plus x plus negative 4x minus 2. When I go through these and factor each part individually, my first term, greatest common factor, we would find is x. And I end up with an x. I need to multiply by 2x to get to my 2x squared plus 1. I'm happy that we did this one with the AC method because I can talk to you about when we get those two negatives there. For greatest common factor, if I have a negative when I'm doing these and it's out in front of the term with my x, I'm going to go ahead and pull that negative out into my greatest common factor because they both have one. And I know the greatest common factor of 4x and 2 is 2. So I know this is plus negative 2. What do I need to multiply a negative 2 by to get to a negative 4x? Well, of course, that's a 2x. To multiply a negative 2 to get a negative 2, I just need to multiply it by 1. And very last step, my parentheses are the same. I can write them down. 2x plus 1. And what am I left with? I have an x for my first part and a plus negative 2, or I'm going to write minus 2 for my second part. We went ahead and factored. All right, let's go ahead and do one more example, and we'll do this example with guess and check. Let's do number 4. Guess and check tells me that I need to break apart my first term after I start 2 sets of parentheses. I know both of them are going to need an x, so I'm going to just go ahead and write those in. And I'm going to look at 2. What's 2 things that multiply together to give us 2? 1 times 2. Is there any other options? Well, no, because 2 is prime. So we can move on to our end term, step 3 of the guess and check. My end term is 18. So I need to start thinking of some of the things that multiply together to get me 18. Right off the bat, I know 1 times 18. I know I could use 2 times 9. I could also use a 3 times 6. I don't think there's any other options other than their negatives, and we'll deal with signs in just a second. So if I go back to my first term comes first in both parentheses. Doesn't matter where I put them, so let's just put in a 2 and a 1. And my last term goes last in both sets of parentheses. So if you want to just start at the top and work your way down, you can. All depends on your preferences. I'm thinking maybe start with 2 and 9. Let's try a 2 here and a 9 here. Well, if I multiply these together and do my outsides, I end up with an 18x. Do my insides, I'm left with a 2x. 18x plus 2x, does that get me to 15? No, it doesn't. It gets me to 20, but not 15. So I don't like those. Which means I have to try something else. Stop coming back. All right, what if I tried 9 here and 2 there? I go through, 2 times 2 gives me 4x. 9 times x gives me 9x. Do those add to get me to 15? No, they definitely do not. So again, I can go ahead and get rid of those. Well, I tried both options for positive 2 and positive 9, so I can go ahead and cross that out. Let's try 3 and 6. What if I put a 3 here and a 6 there? Check my outside terms. 2x times 6 gives me a 12x. 3 times x gives me a 3x. Does 12x plus 3x get me to 15x? Yes, it does. Positive 12x plus a positive 3x gives me 15x. So I can go ahead and say both of these are positive. When it comes to the signs, what I want to see is for a little bit of guess and check. Plug them in. If it's a positive and a positive, then it's positive. If it's a positive and a negative, you might have to rearrange them a couple of times, so make sure you double check. Once I'm done with my guess and check, my final answer is up there. So let's go ahead to our lesson summary. Here's one question. When using the product sum method, you are finding the product and sum of which parts of the problem? I also have a second question for you, and that question is, which method do you find the best? Are you someone who's willing to do guess and check and just try until you get to the right one? And hope that it comes soon? Or are you much more systematic? Would you like to use your AC method? Does that make sense to you? And of course, we have a practice problem. In order to get our stamp, I need to see that you have x squared minus x minus 12 factored on your paper for that stamp. I hope that you liked one of these methods. If you have any questions, please make sure to ask.